Now, a lot of times in scholarship questions, if you read the whole question, there can be a number of elements which can end up confusing you, and it's usually best to start at the start, obviously, and if there's a formula you need to write down, you write that down and you go from there, and often you can work your way through once you get a start on a question. And in this case, we're being told some percentages of iron and nickel, and we're given enough information where we can work out how many moles they are, and we're given a volume so we can work out the moles per litre. We're asked to calculate the concentrations, which is reasonably straightforward, and we're given the solubility product values, and then we're asked to determine a range, a pH range over which iron can be precipitated, so that no more than 0.1% of the iron remains in solution, while none of the nickel iron hydroxide precipitates. Obviously we're going to have some kind of range, and we need to keep that percentage in mind, but the best thing is just to start with working out the concentrations and go from there. So what I've done is we've obviously got 10% of nickel, so 10% times 0.2, which is the mass of steel, that gives us 0.02 grams, and if we divide that by the atomic mass of nickel, we can work out a number of moles there, and that's going to be, in this case, something in the region of 3.41 times 10 to the negative 4 moles. And then if we do the same with iron, we'll find out there's going to be 0.14 divided by 55.9, and that's 0.0025 moles. Now we need concentration, so obviously this is going to be divided by the volume, which we're given as 200 mils, and that will give us the actual concentration. Okay, and that's what I've done, just divided the moles by the volume, obviously remembering it's always in litres, and for nickel we get 0.0100170, and for iron we get the 0.0125 moles per litre. So we've got those concentrations to start with, and now we need to apply that to the rest of the problem. Okay, for Fe3+, we have a concentration which just worked out, and the nickel iron concentration for that. And if we kind of look at these equations, what Ks equals, that could help. So when we look at that, Ks equals Fe3+ times hydroxide iron cubed. Now we know the value for this is 0.01525 times hydroxide iron cubed, and we know the concentration of this is 0.00170 times the hydroxide iron squared. However, we can make a small amendment to this, because we are told that so that no more than 0.1% of iron remains in solution. So in other words, some of this should still remain. So this needs to be divided by 1000 because it's no more than 0.1%. So we just need to alter that. It's going to be 1.25 times 10 to the negative 5, and that's going to be times hydroxide iron cubed. So it would be easy to miss that out, but just got to pay attention to detail, and then we can carry on from there. So we write the equation, and we get 2.79 times 10 to the negative 39 equals the concentration, the 1% concentration of iron times hydroxide iron cubed, and that ends up dividing into that, equals the hydroxide iron cubed. Once we've figured that calculation out, remember to take the cube root, we'll get the hydroxide iron concentration of this. Now obviously that can be turned into a pH, and when we do that we get a pH of 2.78. Well, that's given us one pH value. Now we just have to do the one for nickel up here, which actually should be more straightforward. So if we do this calculation, we've got 5.48 times 10 to the negative 16, which is just the constant we've been given up here, and that's going to equal the concentration. Sorry, that's supposed to be an O there, so I'll just change that, times hydroxide iron squared. If we divide that and then take the square root, we'll get the hydroxide iron concentration from that, which is going to be equal to 5.68 times 10 to the negative 7, and if you turn that into a pH you get something like 7.75. Now, what have we actually kind of worked out here? We've worked out this is the pH at which a precipitate will start to form. It's where solubility is. So below that pH there will be no precipitate, and that's what the question was asking for there. And we've got the minimum amount that we had with the 0.1%,